So we have the function f of x equals 3 times 2 to the x, and it says what are the values of the expression in parts a through c. So you can see for each of these parts they want us to evaluate the function when x is negative 1, when x is 0, and when x is positive 1. We'll do that, and I guess we'll do that first. So let's go ahead and write the function again so we can refer to it. So the function was f of x equals 3 times 2 raised to the x power. So let's consider when x is negative 1 first. Then this function becomes 3 times 2 to the negative 1 power. In order to deal with this negative exponent, perhaps I might do this. I might multiply this by 2 to the first over 2 to the first. When I do that, it turns out that this, right, 2 to the negative 1 times 2 to the first is just 2 to the, oops, that's jumping around, is 2 to the 0 power. So everything I highlighted in yellow is 2 to the 0 power, which equals the number 1. So this becomes a 3 times 1, or just 3, over 2. So there's a 2 down in this denominator. So this becomes 3/2 when I plug in x equals negative 1. What about when x is 0? Well, if x is 0, this becomes 3 times 2 to the 0 power. Well, we know 2 to the 0 power is 1, so therefore this just becomes, the function becomes 3. And I might write this down like this: f of 0 is 3. What I'm saying is when I put 0 into this function, it becomes the value 3. And the last one it says is, what do you get when you plug in a 1? Well, I don't think this is particularly difficult. This becomes 3 times 2 to the first power. 2 to the first power is 2, so this just becomes 3 times 2, or 6. So I might write it like this: when f is 1, the function yields a value of 6. So my answers are f of 1 gives 6, f of 0 gives 3, and I didn't write it down with the correct notation, but f of negative 1 gives 3/2. Now the other thing it says is what value of x makes f of x equal to 12? Well, let's look at this. I want to know, there's something I could put in this function perhaps. This is 3 times 2 to the x power. There's a value of x that I want to know when this function becomes 12. So what I do is I'm just going to place 12, not inside the function, but I'm going to just write the value of the whole function is 12. So the value of the function is 12, or 12 is 3 times 2 to the x power. I'm just solving this for the x. And then I can move forward and verify when I put this x in, it does indeed yield 12. Well, if I divide both sides of that by the number 3, I get 4 equals 2 raised to the x power. So what would I have to raise 2 to the power of in order to get an answer of 4? Well, the answer is 2, right? And the way that we've been approaching it's been a while, but I had to change them so their bases are the same. So I can rewrite this 4 as a base of 2 raised to the second, and over here I've got this base of 2 raised to the x power. Because I see that the bases are both 2, all I need to do is focus on what are the exponents, and it's pretty simple. In this case it just says, hey, x has to be 2. And in some ways it's much more intuitive even than that. The final thing says, where does the graph of this function cross the x-axis? Well, it doesn't cross the x-axis, right? There's an asymptote there. But it also says, where does it cross the y-axis? Well, it crosses the y-axis. Let's see. We know that happens when x is 0, and when x is 0, we got 1, 2, 3. Right? And in fact, at negative 1. I think we had 1.5. So at negative 1 we were at 1.5. When x is 2, it's yielding 6, 3, 4, 5, 6. So 6. And then from there we would have to double that again. So this is a growing function, right? Obviously our multiplier is 2. So it's doing this kind of thing. So this is just kind of a crude sketch.